So our last lesson for chapter 4, we're going to solve quadratic equations. I'm not going to teach you anything new. We're just going to apply what we've learned to word problems. Okay, a lot of the word problems end up being either physics related or finance related. So when you're solving a word problem, you need to look at what information you have, what information you need, and then select a strategy for solving. Right? So first, read the question carefully. That is really important. So many students miss something because they get nervous and they read too quickly and they misunderstand. Next, identify and understand the dependent function, and then do the same to find the independent function. So usually we would write things like y equals x. Right? So x depends on y. Right? So x would be your dependent function, y is your independent variable. Actually, should say variable. All right. Once you've done that, you need to select, okay, what is it you need to find? Are you looking for the roots, the x-intercept, the vertex? What is it you need to find? Now, if you have something in standard form and you need to find the vertex, say the maximum or minimum points, then you're going to complete the square to turn standard form into vertex form. If you want to find the x-intercepts, then you're going to factor. Okay? If you're able to factor directly, that's great. If you're not able to factor directly or by using decomposition, then you can use the quadratic formula. All right. So let's try an example problem. First question says, a cliff diver in Mexico dives from a cliff from about 17 meters above the water. Her height above the water, h, in meters, after t seconds, is modeled by the equation. So the height and time, we have the function for height, right? And it is with respect to time. And it's given to us here in standard form. So it says, how long is the diver in the air before she hits the water? So how long, this is looking for time. So we want to know time. And so if you have a diver, say you're up on a cliff and you dive off, right, over to where the water is. Okay, now this, where you hit the water, since h is the height above water, this is where h is going to equal 0. So what is it we want to find? We want to find time, which is our x-coordinate, right? So technically, since our function is h is a function of t, this is h with respect to time. If I'm just drawing a little grid here, and that's time. So this is height, and that's time. Okay. Once you've done that, you need to realize, what is this point? Well, it has some sort of, I like to say x and y coordinate because we're so used to x and y, but according to this graph that I've drawn, it's t and h. Right? And we want to know that time. So we want to know the x coordinate when we cross that axis. So essentially what we're looking for is the x-intercept, or the root, or the zeros, whatever you want to call it. So to do that, we could try factoring. I can immediately see this is going to be difficult, right? Because we have numbers that have decimal places in it. So it's going to be very challenged to factor. So the other option is to use the quadratic equation. So I set this equal to 0, because that's where height will be, equals minus 4.9 t squared plus 1.5 t plus 17. So here is Here's our A variable. Sorry, coefficient, not variable. Here's our B coefficient, and here's our C coefficient. So let's apply the quadratic formula. So T equals minus B plus or minus square root of B squared minus 4AC all over 2A. And we've done this before. This won't be too bad. I think the hardest part with word problems is actually setting up the problem and figuring out what it is you want to know and how you're going to figure that out. So a couple of things I do recommend is drawing a picture of what's happening. Your graph doesn't have to be completely accurate. You don't need to know exactly how much it's being stretched by, exactly where everything is. Just a rough graph of what's happening. Right? Like a diagram. Draw a diagram. Okay? Once you have a diagram, try to identify what it's asking you. How long is the diver in the air before she hits the water? So the time it takes to go from here until you hit the water to here. If this is your origin, that is where t equals 0, and so we want to know that value of t. Then identify, so is this a maximum or minimum point, or is it a roots or x-intercepts? It'll be the x-intercepts. And you look at what strategies you can use to solve it, and then you solve. So solving this one, you have minus b, so minus 1.5 plus or minus the square root of 1.5 squared minus 4 times a, which is a negative 4.9, times c, which is 17. All divided by 2 times a, which is, again, negative 4.9. Then you can work out what's in the square root, and you can use your calculators for that, and you'll get minus 1.5 plus or minus 18.3, all divided by minus 9.8, and you'll get two values for time, minus 1.7 seconds and 2.0 seconds. So you need to ask yourself, well, which one is this talking about? Okay, it doesn't make sense that this one's talking about the negative 1.7 because that would be going backwards in time here. So this 0 cannot be talking about that one. So let's sort of cross that one out. So it must be talking about this one. So there's our answer to the question. The diver is in the air for 2.02 seconds. Just pause. Alright, so the next example, let's go over how we would start it, and then I'm going to let you guys finish it. First, read the question carefully. Don't rush. A ball is thrown upwards from the balcony of an apartment building and falls to the ground. So let's draw a little apartment. Here's the ground. Here's our apartment building. Okay, I don't know where you are. Let's just put a balcony right there. Maybe you're at the penthouse. And you take a ball and throw it up, and then it sort of comes back down. All right. The height of the ball h in meters above the ground after t seconds is given by this function. So we have this function. It's written again for us right here. Okay. And of course, okay, that would be your height. Okay. And it says above the ground, so the ground will be a height of 0. And this is a height of, well, if you wanted to find out that initial height, that is where you would have your time would be 0. So you could set t to 0, and your initial height would then be 45. So we know that's 45. Maybe I just answered the question. Determine the maximum height of the ball. So I haven't quite answered the question because the maximum height would be here. That's where the maximum height is. And I should have drawn this parabola a little bit more wide. But let's just say, okay, this is a very, very stretched parabola. If that's the maximum height, would I want to use vertex form, factored, or standard? And if we go back to our sheet before, maximum is great, or very easy to determine from vertex form, because vertex form tells you exactly where the vertex is, and that is our maximum minimum point. In this case, our maximum point is the vertex, so we're going to want vertex form. And to do that, we're going to want to complete the square. So that's our strategy for part A. I'm just going to pause there and look at part B. It says, how long does it take the ball to reach its maximum height? Well, the maximum height, your vertex has two coordinates. Okay? It will have your x coordinate, which in our case is time, and a y coordinate, which in our case is h. So the h tells us the maximum height, which answers part A. B tells you the time at your vertex. So that's actually the answer for part B. So if you've already done part A, part B is done too. You just have to recognize that. Then, how high is the balcony? No, that's what I already just figured out. Right? In that case, you're just looking for when time is 0. So you would substitute t equal to 0. Right? And you would be finding h at 0, which equals 45. That one I did right in the beginning. That's really easy in standard form. You can do it in any form you want. But in the standard form, your first two terms just become 0. Right? Negative 5 times 0 squared is 0, plus 15 times 0 is 0, plus 45. So you're just left with 45. So I'm going to pause there, and I want you, now that we have the problem set up, I want you to solve for that maximum point. Okay, I'll give you about 5 minutes. Alright, so let's now complete the square together. So here's our function. H of t equals minus 5t squared plus 15t plus 45. So to complete the square, what we're going to do is first look at our two terms here, just the first two terms, and we're going to pull out a common factor. In this case, negative 5. Okay, only for the coefficients. We're not going to pull out t. We're going to leave that there. Just the greatest common coefficient factor. So that's left with t squared minus 3t. And we still have that 45 over there. Now this next step is where we actually complete the square. So you have minus 5. We're going to take that 3 and divide by 2. So that's 3 halves. And then square it. So the 3 squared is 9, the 2 squared is 4. So we get 9 over 4. And what we'll do is add 9 over 4 and then subtract 9 over 4. Alright, so let's just recap where that 9 over 4 came from. So what you do, use a different color, is take this coefficient 3. Okay, I'll just go up here and do this. So take 3, then divide by 2. In this case, it gives you a fraction. If it was a 4 divided by 2, it'd be nicer, but if we have a fraction, just work with the fraction. Then we square. Now when we square it, the square has to be applied to each value in your bracket. So you get 3 squared divided by 2 squared. 3 squared is 9. 2 squared is 4. Then what we do is we add that fraction and subtract it. That way we're not changing anything. If you take anything and add a number and then subtract the same number, it's like adding 0. Right? We don't change anything. But because we've done that, we now have a perfect square right here. Okay. What do I mean by a perfect square? Let me just do a big bracket. So this trinomial can be factored to t minus, and that same 3 over 2, but without the square, squared. And you can try, test it yourself. Take this, expand it, FOIL it, and see that you get this back. Okay, but this trinomial here factors into that, which is why we call it a perfect square, because this binomial squared, so this binomial multiplied by itself gives us that trinomial. And then we still have this minus 9 over 4 over here, so minus 9 over 4, and we still have this 45. That's going to be sitting out there for a while. Okay, next step, take this negative 5 and distribute it into the bracket there and here. So we first get negative 5 times this t minus 3 over 2 squared. And then we get negative 5 times negative 9 over 4. So the double negative gives us a positive, and 5 times 9 is 45, so we get plus 45 over 4, and then plus 45. Now these are like terms. They're both constants, so we can just add them together. Right? You can see that this is just 11 1/4, and then add it, or you can just use your calculator, whichever. So you get t minus 3/2 squared plus, if you like a mixed fraction, 56, I kind of messed up my 5 there, 56 1/4. I like a mix. Usually I only ever use improper fractions, but in this case, I like the mixed fraction because this tells us a point in our vertex. It actually tells you the height. And since we're looking for height, right, I can easily say, well, 56 1/4, or 56.25 meters. So height is 56.25 meters, and our time to get to that maximum height is our x-coordinate, which is right here. It's the opposite sign of this term, so it's 3/2, or 1.5 seconds. Pause there.